Welcome to Daily Papers.
Imagine you're in charge of a massive fund that gives money to scientists. You're supporting brilliant people who are trying to cure diseases, improve public health, and make the world a better place. How do you actually know if all that research is making a difference?
It's a huge question and a surprisingly difficult one to answer. You can't just count the number of papers a scientist publishes. You need to know if their work has led to a new medical treatment, a change in public policy, or a new community health program. And tracking that kind of real-world impact is a monumental task.
It really is. The paper we're looking at today explains that for just one scientist, it can take a staff member an estimated 15 hours to manually assemble their record. 15 hours of digging through academic databases, university websites, news articles, just for one person. Now imagine you have to do that for hundreds of scientists. It just doesn't scale.
Exactly, which brings us to today's paper, Real-World Evaluation of an AI Agent Drafting Translational Impact Summaries. The authors from the University of Illinois Chicago asked a simple question: could an AI do the heavy lifting for us?
So they built what they call an AI agent. This isn't just a chatbot you ask questions. Think of it more like an AI research assistant. You give it a scientist's name and where they work, and it goes off on its own mission.
It scours the web, searches 5 different research databases, and pieces together a complete file, or what the paper calls a dossier, on that scientist's career. It looks for publications, grants they've won, clinical trials they're running, and any mentions in the news or media.
And here's the clever part. It doesn't just collect links. It tries to understand the impact of the work and categorizes it. It looks for 4 main types of benefits: clinical, community, economic, and policy.
Right. So did their research lead to a new procedure doctors are using? That's a clinical benefit. Did they create a health screening program for an underserved neighborhood? That's a community benefit. The AI finds the evidence, and then for each finding, it writes a simple one-sentence summary of that impact.
This is what the researchers call a human-in-the-loop system. The AI doesn't have the final say. It produces a first draft, and then a human expert comes in to review it. The human's job is no longer to search and write from scratch, but to review, verify, and curate what the AI has found. They can accept a finding, edit it, or reject it.
So, the big question is, did it work? The researchers tested this system in the real world with the actual staff who do this reporting. They had 2 staff members review the AI's work for 10 different scientists.
And the results are pretty staggering. That 15-hour manual task, it was replaced by a review process that took a median of just 14 minutes per scientist.
Let's just pause on that. From 15 hours to 14 minutes. That's a reduction of over 98%. That's not just an improvement, it's a complete transformation of the workflow.
Absolutely. And it wasn't just fast, it was good. The 2 reviewers agreed that about 82% of what the AI agent found was usable. Most of it they accepted as is, and a small portion just needed a quick edit.
This is the key. The AI shifts the human's job from being a detective to being an editor and a judge. The human is no longer spending hours looking for a needle in a haystack. The AI brings them a pile of potential needles, and the human uses their expertise to decide which ones are real and which ones aren't.
So what about the 18% that got rejected? What kind of mistakes was the AI making?
This is one of the most interesting parts. The AI didn't really hallucinate or make things up, which is a common fear. The most common reason for rejection was what the paper calls a weak source. For example, the AI might find a doctor's profile on a generic directory website when the reviewer knows the official university faculty page is the correct source to use.
That makes sense. Other findings were rejected because they weren't quite a completed impact yet, like an activity that was promising but hadn't demonstrated a benefit, or because the AI got the scientist's role wrong on a project, maybe listing them as the lead investigator when they were a consultant.
Exactly. These are judgment calls. They require human context and expertise, which is precisely where the human reviewer is most valuable. The AI handles the legwork, and the human handles the judgment.
And the AI was finding things that manual searches often miss. About a third of the findings were in non-scholarly categories like community engagement or policy work, which are often scattered across the web and hardest to track down.
Ultimately, the paper concludes that this human-AI collaboration works. It makes the impossible task of tracking the real-world impact of science possible on a large scale. Instead of only being able to create these impact reports for a handful of top scientists, an institution could now do it for everyone.
Which is huge. It helps funders make better decisions, it helps universities understand the value they're creating, and it helps everyone see how the hard work happening in the lab actually translates into benefits for all of us. It's a fantastic example of using AI not to replace people, but to superpower them.
It really is. It takes a tedious, time-consuming job and turns it into a fast, manageable, and frankly, more interesting one.
A powerful tool for making sure science gets the credit it deserves for changing the world.